Welcome to Practicon. Today, let's discuss about repeat load and load combination in STAAD. In most of the applications, we use the load combinations and repeat load. If you look into the standards like IS 456 or IS 800 or any international standards, normally there is a load combinations need to be applied for analysis as well as for the design. That means when the structure is loaded with self-weight, we may get wind also, we may get seismic force also, or any other live loads will be acting onto the structure combinedly. So initially the structural engineer will derive the primary load cases like dead load, live load, wind load and seismic load, and finally these need to be applied together with the combination of the factors which is recommended by the standards. So what we do in order to apply these loads into the applications. So first thing is, as I said, the primary load case will be established in order to apply into the structure. Let's say in this example, we have two different types of loads. One is actually self-weight by default. Other one is the member load, maybe we consider as a live load. And the load number 3 is an extra load due to various factors. Maybe associated loads, or maybe the wind load, or maybe the seismic, whatever may be. We applied 3 different type of load cases. Okay, how these load cases will be applied into the combinations with respect to the factors. In STAAD Pro, we have two types of the load combinations can be applied together into the structure to perform the analysis and design. The first one is repeat load. Second one is load combinations. What it means actually, the repeat load and the load combination. Let's make it a little simple over here. A repeat load here, the same loads, for example 1.5 times the dead load, 1.2 times the live load. The load case 1 will be applied into 1.5 and load case 2 will be multiplied by 1.2. Is the same concept can be used in the combination also. For example, the load combination 1.5 times dead load and 1.3 times the live load. So the loads will be multiplied 1.5 and 1.3 times. Okay. Both actually does the same load combinations and the repeat load. But only the difference over here, how it works. If you go to the next slide, I can explain to you in more in detail. For example, in simply supported beam, there is a same load case 1 is a W1. The load case 2 here, I have given something spell mistake, but load case 2 is W2. So what is the bending moment due to the load 1 is WL square by 8. Same thing for the load case 2 also is a W2 L square by 2. Sorry, W2 L square by 8. So there is a 2 bending moments due to the 2 different load cases we extracted. So what it does actually in the application of the load combination, when you do the load combination, the analysis will be performed for the load case 1, WL square by 2, 8, and load case 2 is a WL square by 8. And if you apply the load combination, these results will be combined together. Load case 1 and load case 2 is nothing but WL square by 8 plus W2L square by 8. The results will be combined together. But if you use a repeat load, what will do? The same if you use the load case 1 plus load case 2, W1 and W2, the loads will be summed together and then do the analysis. Over here, there is analysis will be performed only load case 1 and 2 and the results will be combined. But repeat load, load case 1 will be analyzed, load case 2 also will be analyzed, load case 3 also will be analyzed in the repeat load by combining the loads. And the combination of the loads will be applied into the structure and do the analysis. So this is only the difference between two. So how these differences actually will work? For example, there are many situations will help repeat load much better than the load combinations. In fact, I can recommend instead of using the load combination, we always better to go with the repeat loads. It works for every case. Let me explain to you one of the example for that. In case of static load, you see here in a column, there is a horizontal load is a load case 1. The P is the vertical load is another load case acting on the single column member. In elastic analysis, the load combinations, if you apply these things, like a P is one load case, H is one load case, right? And then the static analysis, also called as elastic analysis, is actually it based on the static equilibrium and provides the results according to the, there is an assumption that there won't buckle the member and it provides based on the static equilibrium conditions. So for example, if you want to stress P by A, if you want over here, there is a bending stress H times the length of the member will provide the moment, and based on that we'll get the bending stress. So for elastic analysis, the load combination works fine, no problem at all. Even if you use repeat load, still it works. But in case of P delta analysis or maybe the nonlinear analysis, so if you use the load combinations, what will happen you see, due to the P and due to the axial force P, the member there won't be any deflected and it is remain in the same place. But in P delta analysis, due to this horizontal force, there is a deformation of the delta. So the load P is actually moved the distance of the delta. So there is an additional moment will be induced due to the P times delta at this exactly the support point or in the edge of the member. So what we are trying to say, we can get an additional force due to the deformations. This is called actually P delta analysis, also called as a secondary analysis. So when we go for secondary analysis, it is an important to apply the loads, the combination of the loads as a repeat load, so that the entire load will be applied into the structure, not just the combination of the results. So this is one of the typical example where you can apply the repeat load. But similarly, there are conditions. If you have a truss systems, there is a multiple loads are applied. So the bracing member sometimes it may undergo compression or tension only member will be assigned. These kind of situations also we better go for the repeat load combinations. As a overall, if we apply the repeat load, we are always safe in the analysis and design. Thank you very much. If you have any further questions, please feel free to ask. Please subscribe to the channel for more information about the structure analysis and design. Thank you.